Good morning, everyone. Welcome to our webinar, 8864 Data Controller Firmware Upgrade, What's New and Why It Matters. My name is Dan Napolitan, and I'm a marketing specialist here at ESC Spectrum. Today presenting, we have our Senior Research and Development Manager, Anthony Dougherty. They will discuss the features available in the upcoming 8864 Controller Generation 2 firmware upgrade. In the poll section on the right of your screen, please respond to both questions if your facility plans on purchasing any data controllers in the upcoming year. You can also drop any questions in the questions panel, and we will get those answered throughout the webinar. With that being said, let's begin.
Thank you, Nathan. Appreciate that. Again, my name is Anthony Dougherty. Quick introduction. I've been with ESC Spectrum for over 16 years now. I have a PE in computer engineering, and I've worked in support, engineering, and development, but not in that order, and some days still all three at once. And today I do want to tell you about the current state of the data controller, including G1, G2, and the future of the 8864 in general. So just a quick overview. There are really three sections to this presentation. We want to revisit the hardware service timeline and tell you about some updates to that I think you all will appreciate. And then we're going to cover some bugs that were found in the firmware, what those are and what they mean. And then we'll dive into some features in the new upcoming firmware release. Now, at each of these sections, I want to stop at the end of each section and try to handle questions related to those. I want to limit that to a certain amount of time. So if we don't get all of them, when we stop for questions on that section, we'll pick them back up at the end. I want to make sure we have a chance to cover all the material within the hour that's allotted. If we need to go over at the end of that hour, I'm fine with that. I want to be able to answer all your questions today and get you the information that you need. So let's jump into the hardware service timeline. So we continue to learn from our customers, and for that I want to say thank you. I want to remind everyone of the problems we were attempting to solve with our generational model of the data controller. We were forcing upgrades on people when we would end of life a certain model. And we also had problems continuing to support the hardware, the ability to get the parts that we needed and the ability to produce a certain number of data controllers each year to meet demand, especially when the demand was very high. We'd always have these spikes in uptake when we'd end one model and introduce another model. And there's lots of aggravation that comes with that. When a model suddenly no longer supported because of different security and IT policies, fleets are required to upgrade their entire fleet within a very small window. So these were the problems we were trying to solve. However, I feel like we mistakenly coupled our needs and approach to designing the hardware and the firmware with our ability to service and support your needs, our customers' needs. Customers clearly need up to a 10-year window of service to better plan and manage hardware life cycles and budgeting. So the good news today is that we're decoupling these different items to help simplify our communication on this topic. So let me tell you what that means. First, though, to continue on, part of the problem with the generational model was the G1. The G1 had been in the field since 2014, the 8864 G1. And due to its age, it was a more complex model to shift away from. And there were a lot of elements that were outside of our control. Now, on the screen, I'm showing the G1 timeline. This has not changed in any way. This will remain the same. G1 had full feature development through 2023. It's already ended. We are now in a firmware maintenance cycle for the G1. The G1 will have a maintenance firmware release later this year with a follow-up release near the end of last year, which will be the last release. And that is tied to the fact that we can no longer update the security utilities in the kernel because the long-term supported kernel that we're using will have its last release in January of 2027. So we're going to get our last release out as close to that as possible to get the most updates that we can. We're also extending RMA hardware and product testing through the end of 2028 for the G1. Now, we really wanted to avoid getting in this position going forward. And we continue to learn the best ways to solve the problems we presented with that generational model of each data controller and what that meant for different terms of service for you. A lot of you may recall this. That's the timeline of the model. And I'm intentionally blurring that out because our generation model for G2 and beyond really represented a model by which we solve the problems I've been describing from a development and design perspective and not how we service and support your needs. We've discovered that this model wasn't really useful to you and just created a lot of confusion by sharing our development model to solve these problems. Now, we are always happy to discuss our plans for the future and how we'll continue to strive to make you better at your job. To this end, I want to introduce to you the new and improved service model and all you need to know when considering and planning for a new data controller purchase. Starting today, each 8864 shipped will carry a 10-year window of service per our DAS Protect agreement from the date of shipment from the manufacturer. In the event we're unable to responsibly repair or fix an 8864, ESC Spectrum will issue a loaner to cover the balance of the promised 10-year window. At the end of that window, the customer will need to purchase a replacement unit. Now, this applies to all 8864 shipped going forward, assuming that you maintain an active DAS Protect agreement and/or data controller defense. The good news is that this also applies to G2s that have already shipped. They've been grandfathered in. The same 10-year service window from shipment applies. This will not reduce any service windows that we previously presented, but will actually increase service windows for previously purchased G2 data controllers. Thank you to those that got in early. Unfortunately, this does not apply to G1s. The G1 timeline that I presented on the previous slide still applies and is the same as what we presented for the past several years. So what this really means, if you purchase a G2 later this year, and a few months later you purchase a G3, both of those devices will have 10 months from the date of shipment from the manufacturer of service support from ESC Spectrum. There's really no difference in the service you can get between a G2 and G3. Moving forward, we've decoupled our service timeline from the generational development timeline, but this will not change our continuous development approach on data controller hardware and provide robust, reliable, and sustainable data controller production without interruptions due to supply chain difficulties. And we still believe that producing each data controller generation for a shorter period of time is the best way to meet those production challenges. And the unique landscape we face both today and moving forward into the future, it doesn't seem to be getting any less complex. It seems to actually be getting more complex. But just a reminder and an analogy here of gardening and plant growth, of what the real motivation behind all of this is. So imagine now that we're moving into springtime, you're a gardener tending to a variety of plants in your garden. Each plant has its own growth cycle, with some blooming in the spring, others in the summer, and yet others in the fall. If all the plants bloomed at the same time, you'd have a garden that is vibrant and full of flowers for a short period, but then it would be bare for the rest of the year. To avoid this, you plan your garden so that different plants bloom at different times throughout the year. This way you always have some plants in bloom, creating a continuous and steady display of flowers. This approach not only makes your garden look beautiful all year round, but helps you manage gardening tasks more evenly without overwhelming yourself with too much work at any one time. In a similar way, by retiring and releasing newer models of our data controllers more frequently, we can ensure that our technology remains up to date. This approach helps us manage the rocky landscape of part availability and sustained production. It also smooths out that adoption curve, so our customers are not all upgrading at once, which in turn levels out our production demands over time. Just like in gardening, this approach allows us to keep our technology up to date and our operations running smoothly without overwhelming our resources or you, our customers. We do expect this process to happen organically, much like the natural growth cycles in a garden. By planning and managing our releases thoughtfully, we can create a balanced and sustainable environment where updates and improvements happen naturally and continuously, benefiting both our own internal operations and you. This will also help you plan and manage your budgets over time. We'd ultimately like to get to the point where we are partnering with each of you in planning upgrade cycles so that you're always up to date and we're able to meet that demand. I encourage each of you to reach out to sales@escspectrum.com or Caroline or Reno directly to formulate a plan for your 8864 upgrades. Now, just a quick reminder of the differences between G2 and G3. They really are not that different. The main hardware that is the brains of the G2 will be the same in the G3. The SBC, the single board computer, the display, and the power supply are the three components, and those typically track with each other for any generation that we have. With the added service life cycle of a data controller being 10 years, I recommend not just waiting for the G3. There's no reason a G2 can't meet your needs today and for the next 10 years. The G2 and the G3 will be running the exact same firmware. They'll have the same feature life cycle. The The main things that we're introducing that are changing are a refresh of the I/O card BOM, that's bill of materials. We had some parts that were going end of life and were getting hard to get, so we adjusted the design of those I/O cards to handle that. Now, I will say the card compatibility is still the same. G1, G2, G3 cards work backwards and forwards, but I do not recommend using cards that have been out in the field for years and buying an empty G2 or G3 and taking your old G1 cards and slapping them in there. There's some science behind this. There's some thermal profiles of different parts on those boards. They actually fail over time, and they fail in a way that you don't know that they failed until you need them for protection, and then it's too late. And you could have a situation where protection components can actually cascade further throughout the system and actually doesn't really fit within the UL certification. Taking an old card and putting it into a new system violates the UL sticker that goes on those boxes. That has to be handled at a production facility that has UL audits taking place. Let's see, what else? Current plan is to have G2 and G3 running the same features as discussed above. There's a lot of compatibility between G2 and G3, and is driven by the hardware component availability. Some of the other things that we changed were the daughter board. We had a really old processor on that board. It was more than 15 years old. The company that was producing the chip had been acquired by another company, and there was no clear line of sight how long that would continue to be available. So we changed the data acquisition system. We maintained the performance specifications, but we changed out the processor that was being used on that daughter board. The daughter board is the board that goes in, it's the back plane that the I/O card to plug into. We also had plans for an HDMI card. However, we discovered during FCC testing that HDMI is a known culprit for emissions. I did not know this prior to this. It was very interesting to discover. So we will not have the ability to put an HDMI card. What this would be for is if you wanted to mirror your front panel on another screen somewhere not on the box. We do have the ability potentially to do this in the future using DisplayPort cable. Turns out that technology is much better at not radiating emissions. So if this is something that anybody has interest in, please let me know. Reach out to me directly, adougherty@escspectrum.com, or through your sales rep, and just get that information back to me so I can know if I need to plan to try to get that DisplayPort in on the G4. We ran out of time for getting it into the G3, as we have already gotten the FCC certification, and we are actually in the process of doing UL certification on the G3 right now. Now, because they are so similar, if we had a G2 daughter board fail in the field and we were within the RMA window, it would be feasible to replace a G2 daughter board inside a unit with a G3 daughter board, and that would then become a G3. And as long as that were done within our production facility with the UL certification, it wouldn't violate any of the UL certifications that are being applied based on the way that we are setting up the file with UL. So really, that's not the only difference, is that backplane daughter board. If we swapped out a G2 daughter board for a G3, that would then become a G3 data controller. Again, just because we reach the end of service on firmware or hardware due to parts availability, support will still take your call. We'll still do everything we can to help you with whatever hardware you have. I mean, if Michael Johnson or Scott Floyd pick up the phone and somebody was asking questions about 8816, I'm sure we'd do all we can to help you be successful with that. We do, however, anticipate that G4 will have significant hardware differences. So just a quick overview here, good comparison of Generation 1 to Generation 2 and Generation 3. You can see Generation 3, really the only difference that we have is the SSD card here. It is getting harder to find these smaller 16 gigabyte drives. And so we had to upgrade to a 32 gigabyte SSD on the SBC. But that's really the only differences. And that is really the end of what I want to discuss with the hardware service timeline. So I'd like to take a few minutes here to see if anyone has any questions. And before we do that, I also want to remind you about the poll that's over there on the side. There are 2 questions there that we'd like to get some answers to help us figure out what production needs we need to be able to meet in the coming year through the end of 2026. And with that, I'll turn them over for some questions. If you do have questions, you can type them in the Q&A panel or in the chat.
We've got one from Eric Bowers. What is the expected data storage difference from generation 2 to generation 3 with the storage increase?
That's a great question, and one that we've actually been trying to decide exactly where to land that one. There will be partition differences between G2 and G3 due to the increased storage. We have not actually nailed that down. I guess I would ask back, what do you want it to be? I know that right now the storage is so large, it seems like there's not a limit on what we can accomplish there. Is there a target that you would have in mind would be my question and response. If you want to shoot me an email or throw that in somewhere. We've not nailed that down exactly yet. It'll be at least as much.
I'm not seeing any additional questions, so I think you're good to move on to the next section.
Good. Let's jump into the bugs that were covered in the firmware. I think we do an 8864 G1 update first. Let's see. Yeah. All right, so let's talk about the G1. G1 version 604 was released back in July of 2024. We are currently under development for a maintenance release that's scheduled right now for Q3 of this year. We originally had a Q1 target. Some things shifted around, and we're trying to get that release a little bit closer to the end of the year so that there's a year between this year's release and next year's release. That 605 version will be scheduled sometime Q3 of 2025. It will have all the bugs that I'm going to be discussing in the G2 release that apply to the G1. Most of the bugs are the same. The only bugs that are different are new features in the G2 that had a few bugs. Right now, the firmwares are still tracking pretty closely to each other in terms of the G1 and the G2 firmware for bugs. The G1 will also have a kernel update and some security utility upgrades as part of our proactive stance on security. And again, there will be one more final maintenance release near the end of 2026. Only security updates and bug fixes, no new features. So that's G1. G2, I've got a lot more to talk about. G2 70126 came out also in July of 2024. 8864 version 702 is available now for beta for anyone interested in testing ahead of the May release. We're scheduled for a May 6th release right now. Again, beta release 702.63 is what we're up to. There's a lot of stuff in this release that I'm going to be talking about during this presentation. And again, all the bug fixes shown in G2 are also included in the G1 where relevant. If you have ideas for future enhancements, I would love to hear them. And that being said, let's talk quickly about the bugs that are in the G2 firmware update being released in May. And again, if anybody who has a G2 already and would be willing to do some beta testing on this, reach out to me directly and I can hook you up with a copy of the current version of the firmware. All right, so some of the bugs that we had, I don't know how many people know this, but there is a dashboard, that's the front panel GUI. There is a dashboard control menu in the MDI that allows you to manage the dashboards from the MDI. There was a flicker on that we fixed. We also fixed a polling status. On the polling status on the front panel, there's a little X that indicates whether or not StackVision has pulled data or any other client within the past 5 minutes. That actually never worked, so we corrected that. It'll now show a green check mark if data has been polling. So that's an indicator, if you didn't know about it on the front panel, that if you got a green check mark, you know that your client is polling data within the past 5 minutes. We fixed a small decimal formatting issue with channel data on the GUI dashboard front panel as well. And again, since these are all dashboard related, these are all only G2 bugs. The next one also is the dashboard related bug for digital output login. We had a situation where you tried to set a digital output and you typed in your grid password wrong. It would indicate that the digital output had been set, but it did not actually change and didn't give you any information back that you'd logged in incorrectly. We fixed that one. That's also G2 only. The next two are G2 and G1 both. We had a situation where if you had downloaded all of your calibrations and then sometime later you came along and added another cal, for whatever reason, that cal status would show up on the second page instead of being on the first page with all the rest of them. So we patched that. I doubt many people would see that happen. Probably the one that would affect more folks is the offline cal qualified grace period. We fixed a bug that caused the 8864 G2 to apply a grace period to offline cal qualified parameters. Per EPA regulations, they don't have a grace period. What this bug actually was is you would still go out of control, but the math functions for the indicate grace would report that you were in a grace, even though you're not. And so it really didn't change the behavior, just a change to the update to the math functions to correctly represent that. I consider all of those to be pretty minor bugs. I want to move on to the big bugs. And of the big bugs, we really didn't have any. And again, pause for a moment for questions if there are any. Take about 20 seconds or less. You guys, if you have questions, feel free to type them in as we're moving along. You don't have to wait for me to pause. Anything that we don't see, we'll just pick up at the end. Okay, move on to features. All right, before we dive into the features in this release, I want to say that this is probably the most feature-rich firmware release I've had the opportunity to be a part of. There are 7 major features that any one of which by themselves I would consider to be a major accomplishment, and all 7 of them are in this release. So just a warning, there's a lot I'm getting ready to cover, and it's complicated. So trust me when I act like I sound like I know what I'm talking about. Again, this is all covered in the manual, and those of you that are familiar with these different areas, I'm going to go fast, but I think you'll be able to pick up on what I'm saying. For those that are not familiar, I encourage you to review the manual. The documentation is very dense and it's very thorough. The manual has not posted yet because we've not released the firmware yet, but I'm happy to share the current revision of the manual with anyone who wants it, and you can reach out to me directly. And with that warning out there and that covered, let's dive in. Real quickly, here are the new features I'm going to cover. In general, we made some improvements to the front panel GUI. We added calibrations to the GUI dashboard. We added the ability to upgrade your firmware and keep your configuration. We added the ability to export your current configuration to an XML file. We also added the ability to then re-import that XML configuration and have that be your configuration on your data controller. We added the ability to save on calibration gases by inhibiting your startup calibrations. We added the ability to help stay in control by simplifying the way in math functions like sector OOC kick off automatic calibrations. Many people will have this in their configuration, maybe configured by an engineer for them. We've simplified that so it's easier to use to reduce the implementation time that it takes, but also to give you the opportunity to implement it yourself if it's not something you already have. We added a MDI menu that is a log of calibrations showing how they were initiated, whether it was initiated from some remote client issuing a dashboard command saying start the cal, or if someone did it manually, or if it was started by a digital trigger. You can now go into the calibration log and see when calibrations were started, and also see if a calibration was aborted by a user. We also extended the number of console tasks from 8 to 16. Talk about that in a minute. We added an analog output toggle. So that's an overview of what we're going to talk about. Let's get into each one. All right, in general. So when you're editing a channel or adding a new channel to a dashboard, if you're editing a new channel, when you come in here, there'll be a filter with that channel name on, which prevents you from seeing all the others. We added this clear button so you could quickly get rid of that and select the channel you want. We also added the ability per channel when you're adding a new channel or editing a channel to turn the round precision on. So if you want to see your numbers on the front panel rounded, you can hit this RP button, and per channel you can configure if the value you see on the front panel is rounded or not. We also added a drop-down menu that allows you to change the colors that are displayed. This is really tied specifically to F-flag. We don't have a lot of customization options on colors, but you can at least now not have red show up on your dashboard just because you're offline. You can see there are 4 different options there that you can control. And again, all this is in the manual. And I'm going to move fast because I want to make sure I cover everything. There's another thing you can do here where on these intervals, these are the 4 different intervals you have available for each channel and a large zone display. You can update this in real time by clicking on that interval, and it'll cycle through them. That way you don't have to configure another one just to go see, oh, it's my 1 minute and my 15 minute. You can just click on it, and it'll stay on whichever one you click to. It does not change the configuration of that dashboard, but allows you to cycle through them in the real-time view that you're within. And I'll demonstrate that here in a few minutes. But I want to get into the calibrations on the dashboard. And again, quick warning, I'm going to cover a lot of information quickly, but it's all documented, and it's documented very well in the manual. It's also relatively straightforward. And I feel like intuitive if you're used to dealing with calibrations in any of our other software offerings. We spent a lot of time with the project implementation team going over each one of these and implementing them in a way that collectively made sense to all of us. So here in the top middle, this is what we are calling our Calibration General. And what we'll see is over here on the top left, we'll have the name of the calibration. There's a button in the middle for starting or aborting, depending upon whether it's running or not running. And an indication on the right of the last run calibration status. In the middle, we have the current calibration status, and this matches what is reported. Everything that's shown here matches exactly to what's reported on the MDI cal status screen, if you're familiar with that. Now, to start or abort a calibration, you will need to authenticate. You will have to have authenticated to be able to do that. Now, starting here on the second row, this third column shows large channel zones, but these first two columns show the new calibration information on the front panel. Currently, the calibration is not running. Here in the first column, we have what is a trend view. And in the second column, we have what we are calling a detail view. You configure which one of these you want to show in the dashboard configuration. And if you double click on it, it'll switch back and forth between them, but it will not change the configuration of the dashboard. Currently, the calibration in this screenshot is not running. And so what we'll see is the name of the calibration up here, name of the calibration and the channel in the top left, with the currently displayed phase just below that. You can see I have a scroll bar here, which allows me to switch between phases. Now, these are screenshots of a browser, and I'm going to demonstrate with a browser, but on a front panel, it's pretty slick. You can just swipe, just like on a phone, and you can swipe between your phases so you can see what's there. Up here, you'll see that the calibration and channel name are highlighted in red, but we're in phase 2, which drifted. And so what this means is this status on the top right represents the status of the current phase. The status of the worst phase is demonstrated in color for the calibration and channel name up here in the top left. Okay, for this trend view, we'll see a graph showing calibration results for the configured channel for the last configured number of data points. So again, this is per channel, but it allows you to navigate through all of the phases for that channel within that calibration. And the default for this is 14 data points. So the trend will give you a view of your last 2 weeks of calibration runs. Each one of these data points represents that channel's value for that phase, what the result of that run was. The trend view y-axis is based off the largest configured out of control or maintenance limit. If neither one of those are configured, it'll scale to the largest actual value. If the last data point is off the graph, then the text in the middle of the screen will indicate that. And you can swipe again on the front panel to switch back and forth between the two. You can see that the color represents red for out of control, orange for maintenance, and green for passing. And you can see that this data point up here was a drift, and then it went to an out of control point that was off the graph. And so the color of the line represents the status that it's going to. And that's pretty much everything for the drift view. So let's talk about the detail view. The detail view over here in the second column, again, the calibration and channel name is colored based on the worst status that occurred during the run, but the status of the current phase that you are looking at is shown over here on the top right. And again, you can switch back and forth between phases. The real difference between the trend and the detail is the detail will show you the results of the last cal run. Again, these are both not running. When it's not running, it'll show you the results of the last cal run that happened. Unlike the trend view, the detail view graph over here on the right will scale as large as it needs to show the actual value. So if you have some huge value that's way off scale, your drift and your OC lines will shrink way down here and you won't really be able to see the scale on them. Both the trend and detail view show the maintenance as a dotted line and the OOC limit as a dashed line. So the trend can be thought of as an overview of multiple runs, while the detail is a detailed view of the last single run. Okay. Now I want to get into a use case. And here I'm going to attempt to switch and do a real-time technical demonstration. Typically something always goes wrong, but we'll give it a shot. We are on 22. And here we go. All right, so here we have a live data controller. This is a web view of the page. And I want to show you what each of these looks like. This is the same setup and layout. And I want to show you what it looks like when the calibration is running. Now, before we do that, I want to point out this digital over here on the top right. There is a setting called hold pattern that is configurable on each phase of any calibration. Now, I'm going to activate that before we begin this. This is a setting that was all the way back in the G1. And this is something that I've had multiple different technicians ask me for. And we just recently realized, well, you know, this is already in the firmware and something we can capitalize on now that we have the ability to interact with and see the calibrations on the front panel GUI. So I'm going to turn that on, and what that's going to do is that's going to hold this calibration in this first phase when I start it. Now I'm already authenticated, so I'm going to go ahead and start that off. And what you'll see is that data starts coming in as we're running. So right now the last data is off the graph, so this is good. This is going to be a chance to talk about it for a minute. And since I'm holding, we'll stay in this phase. Okay, so when we're not in data time, you'll see that it goes with a blue color. When we enter data, it goes to a purple color. Same thing you might have noticed, and you'll see it on the next phase when I release out of this phase, is that it'll say run here when we're not collecting data, and it'll say data when we are collecting data points to actually count towards the result. You can see that our counters have stopped counting. This continues to count up, but there is no time left in the phase. This is the configured time of the calibration run. Instrument control cals work in a very similar way. Now you can see that we're starting to take on more data points since we're within the range. We were taking on data points before, but they were outside the scale. You can see that with the data points that don't factor in are over here in the blue. We only color code per status the data points that are going to count towards your result. And so this ability to hold in a phase and tell you where you want to be can be very useful for tuning and other things like that. Now, the status bar up here will be blue when we're not taking on data and purple when we are. So I'm going to go ahead and release this. Oh, before I do, I want to mention the trend only shows status for the number of data points that match the configured data time as data points continue to come in. Now, it looks like it's static because this is a test configuration and it's not moving around, but as the minute flips here, you'll see that we'll start to get new data points where we can recognize that they're new and that we're now passing. And so now that I'm fully in passing and not even drift, I'm going to release it. Of course, this one's going to fail because he was outside of it, and we'll see that status and see he failed. And so now our calibration is flashing fail. If we get a fail or a drift, we will flash that status for the calibration. You can see as we continue on that we're showing data for this one. The last phase is data. So there's our run, then our data for the entire phase. And if a channel is not in a phase, we will display that here on the graph, not in phase, to give you an indication that it's not in phase. And so that's what that looks like when the calibration is running. Again, all documented in the manual. I know it's complex, but I feel like it's somewhat intuitive. And so let's jump back in to the presentation. Okay, so let's move on to some of the other features. So that was the calibration on the dashboards. We also have the ability to upgrade and keep configuration. So in the past, you'd always cold start, you'd lose your configuration, you have to open your client, connect, download your config, compare everything. Now we have the ability, when you're upgrading, to select two new options, USB download and keep config or Ethernet download and keep config. What this will do, I'll go ahead and tell you some of the behind the scenes of how this works. This will create a configuration XML file. It will export it out. And then once that is exported, I see your questions. I'll get to that one at the end. Once that XML is exported out, it will copy that off somewhere. If there's a server.cfg, it'll copy it off. And then it will perform a cold start. Still does the cold start. So if you have take effect on next setting, cold start settings, those are going to kick in. When the unit comes back up, it'll take that config XML, process it into command response strings, feed it into the command response processor, put the server.cfg in place, and that all happens during boot, so it's seamless. We took our largest configurations that take the longest time to download. We have a 64 channel, 20 channel, 64 phase calibration configuration that we do automated testing with. It takes us an hour and a half to download. I tested a regular reboot versus a reboot and keep config with that configuration, and the boot took an extra 20 seconds. Most configurations will take an extra 1 to 2 seconds to do this processing. So it's so quick, you probably won't even notice. We've ran this hundreds of times now, and we've not seen any errors. I'm going to talk a little bit more about that in just a moment. We also have the ability to export your configuration. This will allow you to export the USB or SFTP, that config.xml file I was talking about. This is the same file used by config compare and by DL Suite, and it contains the current configuration constructs of the data controller when the export occurs. Now, because it says export config, it'll copy the existing configuration to a file called config.xml to either USB or SFTP. If it's already present, it'll overwrite it. If you're exporting to USB, because we called it export config, if a server.cfg file currently exists in the SFTP folder, then that file will also be copied to the USB drive at the same time. If it's already present, it will also be overwritten. The export config does not copy the server.cfg to the SFTP, however, because it's already there. And if we did that, we'd be restarting the Modbus thread. So it only copies it over to the USB if you need it to. Now, on download XML configuration, this is import XML basically. You have the ability to then go import that USB either from SFTP or from a USB drive. And this does the same process that the upgrade does without the upgrade. It takes the whatever config.xml you specified, moves it off to the side. If there's a server.cfg, moves it off to the side. And so what you can do is you could upload a server.cfg and a config at the same time, move them over, and then execute this command. Now, you'll notice that it does cold start. There are too many complexities to get in to allow you to put a configuration with something that already has a configuration there. So it will clear everything out and then load whatever you put in that SFTP. When you come back up, it'll be there. I wish I'd have done this years ago. We've been using this in testing, and it's been speeding up our own processes. It's pretty fantastic. Now, if you're upgrading from USB, there was already an MDI menu to import server.cfg from USB. So you'll need to do that step first, and then go do your import XML. And then if you hit XML download with cold start, when it comes back up, everything will be there where you want it to be. And again, this is all documented in the manual. Any server.cfg that's in place when you do this is retained. All right, so we've given you the ability to load all these files, but how are you going to make sure they work? Okay, so there is I don't have it open, there's a restore-config directory that's created in the SFTP directory that anytime you perform one of these upgrade with config or import XML operations, it copies that XML and this, which is essentially the command response documentation of what took place to load that config when all of that happened. We also created an MDI menu, which is on the screen here, where you can go view. It gives you a list of files and they're by date, so you can go view whichever one you want. And so you can go confirm that the last upload that you did had 0 failures. And that's all you really need to do. We've done this, like I said, hundreds of times. We've seen no failures so far. If you do get a failure, it's going to mean either there's a bug somewhere that we got to fix. And so if you find a failure, please create a system report, email it to support, get it to me so we can fix it. Or you've changed something like take effect next cold start, changed the number of your IO cards, and your config doesn't download because it can't download an analog channel, something along those lines. The point is you do have the ability to go look at the operation to verify it was successful. And this works the same way that the server.cfg file navigation does. I would not recommend trying to search through here for an error. If there's an error, go get it from the restore config directory on the SFTP or create a system report and we can dig it out of there. Okay, now let me take a breath. I'm going to take a drink before we get into this next part. Now, to save on calibration gas, we've added some settings to calibrations called inhibit startup digital input pattern and reschedule inhibited startup. I'm going to try to stay mostly high level on this one. It's pretty complex. You have the ability to put in a complex pattern that when evaluated to true will inhibit a startup calibration from running. You also have the ability to allow that startup calibration to be rescheduled or not based on the reschedule inhibited startup setting. So if that's set to yes, An inhibited calibration will continue to reschedule for an hour later for the duration of the grace period. This is the same as if you had a startup calibration scheduled, but you went offline. So the data controller already knows not to run that cal, but to schedule it an hour later because maybe you will be online. And that happens till the grace period ends. That's all already there. This follows that same logic and same pattern. If it's set to no, an inhibited startup calibration is not rescheduled during the grace period unless you have another fully offline hour, in which case it will reschedule the startup calibration. However, if your inhibit pattern remains, then it will prevent that calibration from running. So here's an example of that. And what we see here is a timeline put together. Now, there are a lot of these in the manual, and I'm going to talk about it in just a minute. You can see here that gray represents offline. So here's where the online startup condition occurred. There was a startup calibration scheduled. However, there was an inhibit pattern that evaluated a true that prevented the startup cal from running. And you can tell by the sector OOC clock here, this is the math sector OOC function, that the calibration did not get rescheduled. I think this was actually verified to the MDI status, which I'll show in a minute. But the idea here would be that you would use this in conjunction with the daily calibration that ran online earlier in the day to set an inhibit pattern that you would reset at midnight each day. So the thought is if you've got a unit that starts up and shuts down a lot during the day, or you have a unit that consistently is running when you're 5 a.m. or whatever it is, daily calibration runs, but then it shuts down, but you know you're going to turn on again in the afternoon. This would give you the ability to prevent that startup calibration from running later in the day when you've already completed a successful online calibration earlier in the day. So it gives you a way that you can save on some calibration gas by preventing those additional startup calibrations from running. That's the real motivation and idea behind this one. Okay, another setting we added to calibrations was a way to help to try to stay in control using the math sector OOC functions. There's a setting now called online cal at sector OOC less than or equal to 8 hours. Now we set it at less than or equal to 8 hours just to avoid the complexities that come along with a grace period, because as soon as you enter your grace period, you typically, sector OOC will immediately get another 8-hour jump. So what this will do is the calibration that this setting is configured at will run if any data channel has a math function sector OOC value less than the configured threshold set here, and the channel is online. And again, we've provided some examples in the manual. Here's an example where we came online, an online cal was run to initialize and set all the counters. This was a brand new channel prior to this, which is why it didn't have any data. Again, gray is offline, green is online. And you can see that this just ran all the way until we hit 1 hour. The sector OOC setting on a calibration was set for 1 hour. When that occurred, this sector OOC cal kicked off and reset the timer to 26 hours later. And so theoretically, you could set up a sector OOC setting on your cal and you wouldn't have to program a digital event to kick it off. You just let it run whenever it wants. So where things get complicated is anytime you have multiple settings that all have an interplay. The interaction between the startup calibrations, the inhibit settings, and the sector OOC created some really interesting data scenarios. All of these are covered with the timelines I showed you in the previous slide in the updated data controller manual for this release. These are 11 of those scenarios that are all documented in the manual. We tried to cover all the data scenarios we could find. Again, we worked with project's implementation team on these to set these things up in a way that we determined collectively made the most natural common sense for each possible data scenario. Let me give you an example. Suppose you have a startup calibration that's scheduled, but the sector OOC calibration is scheduled to happen before that startup calibration. Well, so long as the sector OOC value of that channel would not reach 0 before the startup cal would fire, we will wait and let the startup cal happen, which is what we think you would want. You want if your startups to happen like they normally do. You don't want to fire off this rescue calibration just because the startup's going to happen. And this is really based off other implementations that the engineers have done in the past using multiple channels and constructs and configurations. And so we set this up to work in a way that they've discovered over time, over the years of doing these other implementations, that makes the most sense. Because you'll still be in control when that startup cal runs. And for most configurations, that will always be the case because you're going to be in grace period in your startup anyway. However, if your sector OOC would reach 0 before that startup cal would run, suppose you've got a channel that doesn't have a grace period on it for some reason, then that sector OOC will fire so long as the channel's online, and it will fire and it will cancel the startup calibration. If you want to explore all the different intricacies of these different data scenarios, they're all in the manual. And I want to give a shout out to Chris Newby here for the extensive weeks of testing he spent verifying and documenting these behaviors. Some really great work that you've done there. So thank you. Good. All right, so here's an example. Due to the complexity of interplay with settings, there are data scenarios where data can still go out of control because we can't program for everything. We can't program for the things we can't control. So here's a scenario where you're offline, all your clocks have expired, and you go out of control offline. So you can still go out of control. The good news is, though, that once you come back online, the sector OOC cal immediately fires, putting you back in control sooner. Some people might not actually like this because you might want to have some time to come up and get steady before you run your cal, but that's the way that that sector OOC works in that scenario. And this scenario is also documented in the manual. What we discovered near the end, we thought we were done with that, and we realized, oh, this changes all the cal statuses. So we went and updated the cal statuses. There's a polling command that we had to add as well to get the clients updated. That will be coming in the future. But in the meantime, you can see typically you'd have a startup setting. Well, if that startup cal would be inhibited, if the inhibit pattern is true when you're looking at this screen, it'll show you that it's going to be inhibited. That pattern goes away, well, then the very next second, you'll see, oh, it's going to run at instead of inhibit at. And here we have the two different possible scenarios for a sector OOC cal. If your sector OOC on a math channel configured in a calibration gets below the threshold, and that sector OOC cal would be scheduled to run at a certain time. This is if this is if you have not hit the threshold yet, but you know you're going to hit it at a certain time. This is when you would hit that. And this actually becomes the default status. When I showed on that previous slide that the sector OOC counter had reset, instead of a calibration just saying pending, it would now say sector OOC cal runs at this time. And so this is what you would use if you only had the sector OOC set up to run your cal. And then the second scenario that we see here at the bottom, this white line, this is if you're past the threshold, but you're offline. This is that scenario that I showed where it went out of control, unit was offline, didn't kick off again until it came online. Because it won't run the cal while you're offline because it doesn't count. Now, we did also add some stuff where if you abort the calibration for some reason, let's say you're running a sector OOC cal and you abort it, or the unit goes offline, something happens, the cal doesn't finish. We then disable the sector OOC cal settings for all of those channels that were affected by that calibration. That way, it's not constantly trying to run the sector OOC cal. When we disable that setting, it's documented in that calibration log that I demonstrated for the MDI. So you'll know when we re-enable them, that's also documented there. They're re-enabled the next time an online cal runs. So I feel like we spent a lot of time covering all the different data scenarios to get this thing as robust as possible coming out the gate. Spent a lot of time testing it. Here's that calibration log that I mentioned, showing calibration started from the GUI, where one was aborted, where one was started from an MDI, digital pattern, etc. This is very similar to the system log and the MDI. And I believe this comes in the system report as well. If you have questions about how things are happening, could always generate a system report and then get that over. Another thing that we did was we increased the number of console tasks from 8 to 16, and we isolated task 0 from the MDI front panel. So now even if something's gone wrong and somebody's taken up all your tasks with some remote client running a whole bunch of emulation sessions, you can still get to the MDI from the front panel. Task 0 is now reserved for the MDI front panel. And we added an analog outputs toggle that allows you to toggle between engineering units and milliamps by hitting Control A, so you can very quickly see, oh, well, what is that in my engineering units? Does that make sense? Does that come out right? And I know I went quick, but that's because I wanted to leave time for questions, and we are now there.
All right. We've got a few questions. First one from Kristen Conant. She asked, are we able to hold N with any type of gas?
So the way that hold pattern works is it will hold that phase until that digital pattern clears. So I think the answer to your question is yes, but if we need to follow up later, maybe I'm missing the specifics of the question, I'm not sure. But it's designed to work against the phase. So yes, you should be able to.
All right. And Eric Bowers asked, how does the cal screen work and display with I-type cals?
So I tried to mention, I don't know if you noticed with the hold pattern, how it showed that the right side was counting, but the left one wasn't. I-type cal works in a similar way. It's pretty intuitive. I've got an example. If you want to do a screen share sometime, I can show you what that looks like. It does look at like configured data time, and that's how the top one tracks, but the bottom one tracks the same way that the hold pattern did, where it just counts how long you've been in the phase versus how many data points you need. And then once you get the number of data points you need, the right side just goes to 0 and the left side continues on. So it does work with I-type. We worked with I-type from the very beginning of the implementation of this because we knew that it was going to need some subtle differences. It works pretty good.
And Cindy Whitaker asks, I assumed it might change to hold in phase 1. Once 0 was done, why hold 0? Why only hold 0?
Oh yeah. So if I understand your question, two things. One, my hold in 0 digital description didn't match my phase description, and that's just a label. I didn't have time to patch up the labels that were on this test configuration. That whole pattern is specific per phase, and you can configure different patterns for different phases. So you could have instead of having channels down the right side, you could have digitals that allow you to hold in whatever phase you want to and configure it that way. And so really the whole pattern, I've had technicians ask for it, and I've been told that there are other software systems that do that already. There was some thought that, hey, is this really still a hands-off calibration if you do this? And we feel like the answer is yes. I don't know if that's debatable because you are controlling how long you hold in your data time, but there's nothing in the regulations that specifies your data time has to be any certain amount. So this would be more of a situation where I could definitely see this being used for dialing in your settling times and figuring out how long your phase needs to be versus how long your data time needs to be. Or if you're in a maintenance situation, but using them on a day-to-day basis, that's a little more, I think, within the realm for each person to decide. And the features are for G2. There are no features in G1. G1 doesn't have the dashboards. So everything that I just demonstrated, everything in the features section is G2 only.
Okay. And Vincent Dougherty asked if the presentation will be posted for future review. It will be available immediately at this link afterwards, and within the next week, we will be uploading it to our customer community. I think that's all.
Fantastic. If you guys have any other further questions or want to follow up with me on some points of clarification, feel free to reach out with me directly. I'm always happy to help.